Hello dear students, welcome to the lecture 14 of software engineering course. Today's topic is security engineering, and we are going to cover these below topics.
Security engineering and security management. Security engineering concerned with applications, security management with infrastructure. Security risk assessment. Designing a system based on the assessment of security risks. Design for security. How system architectures have to be designed for security.
Okay.
Security engineering. Tools, techniques and methods to support the development and maintenance of systems that can resist malicious attacks that are intended to damage a computer-based system or its data.
So what is security engineering? It is a composition of tools, techniques and methods to support development and maintenance of systems that can resist, this is the important part, malicious attacks that are intended to damage a computer-based system or its data. So this is what is about security engineering.
A subfield of the broader field of computer security. Assumes background knowledge of dependability and security concepts, Lecture 10, and security requirements specification, Lecture 12.
Okay, let's continue.
Application, infrastructure security. Application security is a software engineering problem where the system is designed to resist attacks. Infrastructure security is a systems management problem where the infrastructure is configured to resist attacks. The focus of this lecture is application security.
So infrastructure security is another topic different than the application security.
System layers where security may be compromised.
Okay, so there are multiple system layers where security may be compromised, such as application layer, reusable components and libraries, middleware, database management, generate shared applications such as browsers, emails and such, and operating system.
System security management. User and permission management. Adding and removing users from the system and setting up appropriate permissions for users. Software deployment and maintenance. Installing application software and middleware and configuring these systems so that vulnerabilities are avoided. Attack monitoring, detection and recovery, monitoring the system for unauthorized access, design strategies for resisting attacks and develop backup and recovery strategies.
So you see there are three main layers of system security management: user and permission management, software deployment and maintenance, attack monitoring, detection and recovery. Okay, security risk management.
Risk management is concerned with assessing the possible losses that might ensue from attacks on the system and balancing these losses against the costs of security procedures that may reduce these losses. Risk management should be driven by an organizational security policy.
It is impossible to 100% make the system secure. So you have to consider a balance between security and risk, because having higher security means spending more on security. Therefore, you have to keep a healthy balance between security and the cost of security management. So the risk management involves preliminary risk assessment, lifecycle risk assessment, and operational risk assessment. So the preliminary risk assessment is like below.
Preliminary risk assessment.
Assessed representation and organization, and asset value assessment, threat identification, and exposure assessment. And threat identification is attack assessment, and it takes taken into consideration technology choices. It is also being used in attack assessment. Then control identification, available controls, design and requirements changes. So you see these figures show which are being used by which control and system.
Misuse cases. Misuse cases are instances of threats to a system. Interception threats: attacker gains access to an asset.
So when an interception attack happens or threat happens, attacker gains access to an asset. It can be anything, such as your network card, your graphic card, your operating system, etc.
Interruption threats: attacker makes part of a system unavailable.
So if an interruption attack happens, part of your system becomes unavailable, such as the attack disables your mouse and you can't use it anymore, or other things.
Modification threats: a system asset if tampered with.
Okay, so if attacker modifies an asset of a system, that is modification attack, such as they modify your sound card software and it still works, but they can then listen your sounds and such.
Fabrication threats: false information is added to a system.
This can be such as they are adding an illegal content on your device and then they report you to authorities, and this is fabrication threat. So asset analysis, there are asset column here and value of an asset and the exposure, what happens. So the asset, the information system itself as an asset, the value
High. Required to support all clinical consultations. Potentially safety critical.
Okay, so this is asset analysis of medical healthcare, mental healthcare system. Okay, so what happens if the asset, the information system asset exposure get exposed?
High. Financial loss as clinics may have to be cancelled. Costs of restoring system. Possible patient harm if treatment cannot be prescribed.
Okay, so the patient database of the mental healthcare system value
High. Required to support all clinical consultations. Potentially safety critical. High. Financial loss as clinics may have to be cancelled. Costs of restoring system. Possible patient harm if treatment cannot be prescribed.
Okay, and then an individual patient record. Okay.
Normally low, although may be high for specific high-profile patients.
So if your profile, let's say the president of your country, and exposure of that patient record can cause a lot of damage and harm your reputation and such. So it depends on the profile that is being exposed.
Low direct losses but possible loss of reputation.
Okay. And threat and control analysis. So the threat, number one threat.
Unauthorized user gains access as system manager and makes system unavailable.
So probability is
Low.
Control.
Only allow system management from specific locations that are physically secure.
So if you allow system management to be possible from only specific locations, it is very low for a threat actor to gain unauthorized access. So the feasibility of control.
Low cost of implementation, but care must be taken with key distribution and to ensure that keys are available in the event of an emergency.
So it can be done, it is feasible.
Unauthorized user gains access as system user and accesses confidential information.
Okay, this is high. Why it is high? Because
Require all users to authenticate themselves using a biometric mechanism. Log all changes to patient information to track system usage.
Because if users are logging in with their password and let's say their national ID, and if they are using easy to guess passwords, the hackers can gain access to their profile easily with guessing weak passwords. Okay, so the prevention of such incident is, let's say, force users to log in with biometric mechanism, which cannot be obtained without physical interaction. However, it is extremely hard to achieve that.
Technically feasible but high-cost solution. Possible user resistance. Simple and transparent to implement and also supports recovery.
So requiring biometric mechanism is very hard to achieve. It is technically feasible but high cost. Logging all changes to patient information to track system usage, it is very easy, simple and transparent to implement. So if such incident happens, you can then roll back patient information modification and it is done. You have solved the problem.
Security requirements. Patient information must be downloaded at the start of a clinic session to a secure area on the system client that is used by clinical staff. Patient information must not be maintained on system clients after a clinic session has finished. A log on a separate computer from the database server must be maintained of all changes made to the system database.
Okay, so these are the security requirements of such system and life cycle risk assessment.
Life cycle risk assessment. Risk assessment. While the system is being developed and after it has been deployed, more information is available: system platform, middleware, and the system architecture and data organization. Vulnerabilities that arise from design choices may therefore be identified.
So what are the life cycle risks and how do we assess them? So the risk assessment while the system is being developed and after it has been deployed. More information is available after it is deployed. System platform, middleware of the system architecture and data organization. Vulnerabilities that arise from design choices may be therefore be identified after the system deployed. Okay. So let's see the lifecycle risk analysis. Asset representation and organization, asset value assessment, trend identification, exposure assessment, design and requirements changes, and after we done attack assessment and control identification, there's technology choices and available controls. Okay, let's continue. One moment. Okay, let's continue.
Design decisions from use of COTS.
Okay, so what was the COTS? Okay, so commercial off the shelf. It means that you are buying a system, readily available system.
System users authenticated using a name-password combination. The system architecture is client-server with clients accessing the system through a standard web browser. Information is presented as an editable web form. Vulnerabilities associated with technology choices.
So the technology choice, login password authentication. We could also choose biometric authentication, but we have preferred login password authentication. And what vulnerabilities there are? User set guessable password, as I mentioned a little bit ago. Authorized users reveal their passwords to the unauthorized users. This is another key case. And another technology we choose, client-server architecture using web browser. We could also choose a specially developed application. However, we choose the readily available one, web browsers. Server subject to the denial of service attack because everything is exposed to the public. Confidential information may be left in browser cache. It is another possibility, especially if client is logging from a public area, public computer, public device. Browser security loopholes lead to unauthorized access. If the browser is not secure enough, if the client's browser it may be outdated, it may be not a popular and secure one. It is another vulnerability. And use of editable web forms. We could have used another way to modify the system. Fine-grained logging of changes is impossible. Authorization can't be varied according to user's role. Okay.
Security requirements.
Okay, these are the security requirements of commercial of the shell systems.
A password checker shall be made available and shall be run daily. Weak passwords shall be reported to system administrators. Access to the system shall only be allowed by approved client computers. All client computers shall have a single, approved web browser installed by system administrators.
By the way, the client here is being the employers using the mental health care management system, not the patients themselves.
Operational risk assessment. Continuation of life cycle risk assessment but with additional information about the environment where the system is used. Environment characteristics can lead to new system risks. Risk of interruption means that logged-in computers are left unattended.
Okay, design work for security, architectural design.
How do architectural design decisions affect the security of a system?
So, good practice.
What is accepted good practice when designing secure systems?
And design for deployment.
What support should be designed into a system to avoid the introduction of vulnerabilities when a system is deployed for use?
So let's see the architectural design.
Two fundamental issues have to be considered when designing an architecture for security.
First, fundamental issue is protection. How should the system be organized so that critical assets can be protected against external attack? And the other issue is distribution of the system. How should system assets be distributed so that the effects of a successful attack are minimized? These are potentially conflicting. Why?
If assets are distributed, then they are more expensive to protect. If assets are protected, then usability and performance requirements may be compromised.
Okay, so the protection, platform level protection,
Top-level controls on the platform on which a system runs.
and application level protection.
Specific protection mechanisms built into the application itself, e.g., additional password protection.
And record level protection.
Protection that is invoked when access to specific information is requested.
Okay, this is, for example, when you try to change your password on a logged in system such as your Gmail, it asks you to re-enter your password. Okay, and or maybe your age, your other specific information that you have provided previously. This could prevent such cases that, for example, you have logged in your Gmail account on a public computer and you forgot to sign out, and another person comes in and tries to change your password or another information of your account, then the password or other information would be asked. So this is record level protection.
These lead to a layered protection architecture.
Okay, a layered protection architecture, platform level protection, system authentication, system authorization, file integrity management, application level protection, database login, database authorization, transaction management, database recovery, record level protection, record access authorization, record encryption, record integrity management, and patient records. So the distribution.
Distributing assets means that attacks on one system do not necessarily lead to complete loss of system service. Each platform has separate protection features and may be different from other platforms so that they do not share a common vulnerability. Distribution is particularly important if the risk of denial of service attacks is high.
So distributed assets in an equity trading system. You see there is authentication and authorization, New York trading system and London trading system, US user accounts, international user accounts, US trading history, US equity data, international equity prices, US funds data, and another one, UK user accounts, international user accounts, UK trading history, UK equity data, international equity prices, UK funds data, then Frankfurt trading system, European users accounts, international user accounts, European trading history, and such. You see, the equity trading system is split into four main parts, and they are based on London trading system, Hong Kong trading system, Frankfurt trading system, New York trading system. If London trading system gets unavailable, then they may use international user accounts of Hong Kong trading system and such, or the other areas may still continue working. So the key points of the first chapter is like this. Let's read each of them.
Security engineering is concerned with how to develop systems that can resist malicious attacks.
Okay, even if you are not a security engineer, when you develop a system, you have to always consider there will be malicious attacks against your system. Okay, even if you are developing a system for a single user, you have to consider that fact because it may happen and take necessary precautions.
Security threats can be threats to confidentiality, integrity, or availability of a system or its data.
So there can be multiple different threats such as confidentiality, integrity, or availability of a system or its data. You have to consider all of these possibilities.
Security risk management is concerned with assessing possible losses from attacks and deriving security requirements to minimize losses.
Okay, so there is another area which is security risk management, and the management team is concerned with the assessing possible losses. So they evaluate that if we take this security measure, what can we protect, and if we don't take it, what can happen, and what is the cost of that. With balance and cost of risk, with cost of risk and security protection, they keep the balance. Okay, and finally,
design for security involves architectural design, following good design practice and minimizing the introduction of system vulnerabilities.
okay, so now part 2, I will take a pause. Okay, so the part 2. In the part 2, design guidelines for security, guidelines that help you design a secure system, design for deployment, design so that deployment problems that may introduce vulnerabilities are minimized, system survivability,
System survivability.
allow the system to deliver essential services when under attack. Okay.
Design guidelines for security engineering.
Okay.
Design guidelines encapsulate good practice in secure systems design. Design guidelines serve two purposes. Design guidelines encapsulate good practice in secure systems design.
Okay, it has been multiple times. Read it.
Design guidelines serve two purposes. They raise awareness of security issues in a software engineering team. Security is considered when design decisions are made. They can be used as the basis of a review checklist that is applied during the system validation process.
Okay, so you see, raising awareness is really important among developers because eventually the developer has to be careful when designing and developing a system, and the developer has to be aware of what could be used as a vulnerability of a system. Moreover, they can be used as the basis of the review checklist that is applied during the system validation. So having design guidelines are extremely useful.
Design guidelines here are applicable during software specification and design.
Okay,
Design guidelines for secure systems engineering. Security guidelines.
so let's read them.
Base security decisions on an explicit security policy. Avoid a single point of failure. Fail securely. Balance security and usability. Log user actions. Use redundancy and diversity to reduce risk. Validate all inputs. Compartmentalize your assets. Design for deployment. Design for recoverability.
Okay, so if we order them with the importance from my perspective, from my point of view, I would say number one is validate all inputs. This is number one rule. Never trust any input. Validate it, sanitize it. Okay. And then fail securely. This is another important one. And third one is log user actions. Fourth one is, I would say, balance security and usability. And then use redundancy and diversity to reduce risk. And base security decisions on an explicit security policy. And design for deployment, design for recoverability, and compartmentalize your assets. Okay. So design guidelines 1 to 3. Let's read their definition.
Base decisions on an explicit security policy. Define a security policy for the organization that sets out the fundamental security requirements that should apply to all organizational systems. Avoid a single point of failure. Ensure that a security failure can only result when there is more than one failure in security procedures. For example, have password and question-based authentication. Fail securely. When systems fail, for whatever reason, ensure that sensitive information cannot be accessed by unauthorized users even although normal security procedures are unavailable. Balance security and usability. Try to avoid security procedures that make the system difficult to use. Sometimes you have to accept weaker security to make the system more usable. Log user actions. Maintain a log of user actions that can be analyzed to discover who did what. If users know about such a log, they are less likely to behave in an irresponsible way.
This is similar to have security cameras. Okay, when a person knows that there are security cameras, they are recording everything, they tend to obey and follow rules much better and avoid from illegal actions.
Use redundancy and diversity to reduce risk. Keep multiple copies of data and use diverse infrastructure so that an infrastructure vulnerability cannot be the single point of failure.
And the number one rule, most important one, according to me.
Validate all inputs. Check that all inputs are within range so that unexpected inputs cannot cause problems. Compartmentalize your assets. Organize the system so that assets are in separate areas and users only have access to the information that they need rather than all system information. Design for deployment. Design the system to avoid deployment problems. Design for recoverability. Design the system to simplify recoverability after a successful attack.
Okay.
Design for deployment. Deployment involves configuring software to operate in its working environment, installing the system and configuring it for the operational platform. Vulnerabilities may be introduced at this stage as a result of configuration mistakes. Designing deployment support into the system can reduce the probability that vulnerabilities will be introduced.
Okay, software deployment. Understand and define the software's operational environment. Configure software with the environment details. Install software on computers where it will operate. Configure software with computer details. So you design the deployment basically.
Configuration vulnerabilities.
Okay, the most important vulnerability of configuration is
vulnerable default settings.
I think I have shown you an article on Ars Technica which was showing the MR-scan devices were using default password. Okay, radiology devices. This is, you see how much they make the system vulnerable. If you use default password, then they can access all the devices that are connected to the internet. It applies to everything basically. For example, if your refrigerator is, let's say, intelligent, has IT capability, internet, then if you use default password, it becomes a victim. Or security cameras or intelligent TVs, whatever connected to the internet. If you are using default password, then you are in danger. Okay.
Attackers can find out the default settings for software. If these are weak, often to increase usability, then they can be exploited by users when attacking a system. Development rather than deployment. Some configuration settings in systems are designed to support development and debugging. If these are not turned off, they can be a vulnerability that can be exploited by attackers.
This is also true. For example, when developing a software, it displays all the errors in details. So if you deploy your system within that configuration, the attackers may cause unhandled exceptions to see, let's say, to see important data related to your system, and this is a vulnerability. So deployment support 1
includes support for viewing and analyzing configurations. Make sure that the system administrator responsible for deployment can easily view the entire configuration. This makes it easier to spot omissions and errors that have been made. Minimize default privileges and thus limit the damage that might be caused. Design the system so that the default privileges for an administrator are minimized. This means that if someone gains admin access, they do not have immediate access to the features of the system.
Deployment support 2
localize configuration settings. When setting up a system, all information that is relevant to the same part or component of a system should be localized so that it is all set up at once. Otherwise, it is easy to forget to set up related security features. Provide easy ways to fix security vulnerabilities. When problems are detected, provide easy ways, such as auto-updating, to repair security vulnerabilities in the deployed systems. System survivability. Survivability is an emergent system property that reflects the system's ability to deliver essential services whilst it is under attack or after part of the system has been damaged. Survivability analysis and design should be part of the security engineering process.
Importance of survivability. Okay. Our economic and social lives are dependent on computer systems, critical infrastructure, electricity, gas, telecommunications, transport. These are all dependent on electronic systems, healthcare, government. Loss of business systems for even a short time can have very severe economic effects, such as airline reservation systems, e-commerce systems, payment systems. And then service availability.
Which system services are the most critical for a business? How might these services be compromised? What is the minimal quality of service that must be maintained? How can these services be protected? If a service becomes unavailable, how quickly can it be recovered?
So these are the questions that needs to be answered.
Survivability strategies.
Resistance and
Avoiding problems by building capabilities into the system to resist attacks.
this is the number one rule that we want to achieve, avoiding problems. Recognition.
Detecting problems by building capabilities into the system to detect attacks and failures and assess the resultant damage.
And finally, the recovery.
Tolerating problems by building capabilities into the system to deliver services whilst under attack.
Okay, stages in survivability analysis. Review system requirement and architecture, identify critical services and components, identify attacks and compromisable components, identify soft spots and survivability strategies, then again review system requirement and architecture. So it is an iterative process and you analyze, take action, review again, analyze, take action, review again and such. So the key activities are system understanding, review goals, requirements and architecture, critical service identification, identify services that must be maintained, attack simulation, device attack scenarios and identify components affected. And this is also kind of white hat hackers are trying to penetrate systems and find vulnerabilities such as hackathon. You can also join hackathons. Okay, it is written like this. And survivability analysis, identify survivability strategies to be applied.
Trading system survivability. User accounts and equity prices replicated across servers so some provision for survivability made.
So if they are replicated, if one system fails, another one can continue operating. This was the case. This is usually a case in healthcare systems such as in hospitals. They also keep a redundant clone server as the main server, and therefore if the main server fails, the clone server takes the control immediately. Therefore no process is interrupted. It is extremely important for hospitals to operate continuously and many other systems. So replicated servers are a great system survivability.
Key capability to be maintained is the ability to place orders for stock. Orders must be accurate and reflect the actual sales, purchases made by a trader. The critical service that must survive is the ability for authorized users to place orders for stock. This requires three components of the system to be available and operating reliably. User authentication, allowing authorized users to log on to the system. Price quotation, allowing buying and selling prices to be quoted. Order placement, allowing buy and sell orders to be made.
So possible attacks, what are they?
Malicious user masquerades as a legitimate user and places malicious orders for stock, with the aim of causing problems for the legitimate user. An unauthorized user corrupts the database of transactions, thus making reconciliation of sales and purchases impossible. Survivability analysis in an equity trading system.
Okay, so the attack, unauthorized users places malicious orders. The resistance, what could be the resistance against this attack? Require a dealing password that is different from the login password to place orders. So this is two different protection, two-stage protection. Recognition, send a copy of orders by email to authorized users with contact phone number so that they can detect malicious orders. Usually you see that when you log in your, for example, Gmail account or your Twitter account from a different IP or a different device, you get a notification from your other logged in IP devices or to your email that you have logged from this location. Do you know that login and such? So this is recognition. Maintain users order history and check for unusual trading patterns. And what is the recovery?
Provide mechanism to automatically undo trades and restore user accounts. Refund users for losses that are due to malicious trading. Ensure against consequential losses.
Okay, so another attack type is corruption of transactions database. So the protection, the resistance for this attack
Require privileged users to be authorized using a stronger authentication mechanism, such as digital certificates.
and recognition.
Maintain read-only copies of transactions for an office on an international server. Periodically compare transactions to check for corruption. Maintain cryptographic checksum with all transaction records to detect corruption.
And recovery.
Recover database from backup copies. Provide a mechanism to replay trades from a specified time to recreate the transactions database.
Okay, so the key points of the chapter 2.
General security guidelines sensitize designers to security issues and serve as review checklists. Configuration visualization, setting localization, and minimization of default privileges help reduce deployment errors. System survivability reflects the ability of a system to deliver services whilst under attack or after part of the system has been damaged.
Okay, this was the last lecture of our course, and so let's recap or repeat our final project details. Okay. Okay.
A. Project details. 1. First of all, you will determine a project. 2. As soon as you determine your project, you can start working on it. 3. The project can be a web application, mobile application, desktop application. 4. The project has to be a project that would likely to be used on business life. 5. The project scale is totally up to you, but it has to be complex enough to apply software engineering logic. 6. You can do the project either solo or as a 2-developer team. 7. If you decide to do the project with one of your friend as a 2-developers team, both of you please email me and let me know that you want to work together. 8. The project has to be developed by using GitHub or Bitbucket code management systems. 9. You have to properly commit, push, merge, pull request, and such. 10. You can find necessary related information about code management on the internet.
So this is really important. By checking your commit, push, merge, pull request history, I will be able to see which part of the project you have developed if you are working as a 2-developers team. Moreover, having experience on how to use a code management system is extremely crucial, because nowadays every decent company uses code management to develop software and share the software development workload between multiple developers.
11. You can use Git Bash or any program for code management. 12. You have to develop software with versioning such as version 1.0.0 and the 1.0.1 and then 1.0.2, etc.
Okay.
13. You have to make a layout and summary of your project and ask me before starting it. So I will approve your project. 14. Send me your project layout and details by email, furkan.gözükara@toros.edu.tr. 15. You can do the project in any programming language with using any database management system such as using C#, PHP, ASP, .NET, Python, MS SQL, MySQL, SQLite, etc. 16. Rather than the project itself, how well you apply software engineering approaches and methodologies on your project matter more. 17. You will prepare a detailed report about your project which will include below software engineering diagrams, tables, descriptions, etc. 18. In addition to the project, you will record a video which will be explained at the end of this document. B. Which diagrams, tables, descriptions will be prepared for the project?
Okay, you are supposed to do as many as of them in your project, and according to your efforts and what you have achieved, I will grade your score. Okay.
A professional drawing software is a must like a Microsoft Visio or Microsoft Office.
I don't want you to use Paint.
1. Which one will be your project model? Waterfall, incremental or reuse-oriented development? Lecture 2. Explain in details and why. 2. Write full story of your project features for each feature. Example case, a prescribing medication story in lecture 3, page 21. 3. Write detailed test case of your project features for each feature. Example case, test case description for dose checking in lecture 3, page 31.
Okay, it continue. You can read them. So,
C. General things that needs to be considered. Every project will be controlled one by one. So if you cheat or bring a ready code project, you will get FF. There will not a final exam. Your grade will be based on this project. Thus, take this project very seriously and start working on it immediately. Look the internet for the parts that you do not know. Write your code with as many as possible explanations. What does do that code block? Of course, put those explanations into your code with comment blocks such as or ***. Create an account on https://stackoverflow.com/ and ask there, or look for answers there.
okay, you can also contact me by Discord channel, and latest project delivery date is end of finals, but you can also deliver at the bütünleme exams, you know them. Okay, let's read this part as well.
1. Lastly, everyone will record a very detailed video to explain the project. 2. Video will be recorded with OBS Studio in 1080p, high quality so that I can read explained code easily. Resolution. 3. It is mandatory to use microphone when recording and explaining the project verbally by speaking. 4. Turkish students can record the video in Turkish. 5. The project has to be made in English. 6. Non-Turkish students can also record their video in Turkish if their Turkish is better than their English. However, they should use English if their English is better than their Turkish. 7. When explaining your project, you need to explain every piece of your written code.
Okay.
8. What does that particular code piece or that particular class or that particular method, etc. And how did you write it? 9. Moreover, you have to explain and show every feature of your application. So run your application and do example of every feature that your application have. Let's say you have made an e-commerce website application. Then, show how to search, add to chart, make purchase, this can be demo, list categories, etc. 10. Then after you have to upload your video to the YouTube and set visibility as public or unlisted.
Okay, so about YouTube, you can also upload to Google Drive. Actually, Google Drive is even better because YouTube reduces quality even if it is not much, and therefore you can upload to YouTube, like Google Drive. Okay, and let's continue.
Because it has to be accessible. 12. Furthermore, add your YouTube video link to the project folder as text. 13. Finally, zip or RAR your entire project and upload to your Google Drive. After you get your Google Drive upload link, send me that link as email, furkan.gozakara@toros.edu.tr14. When sharing your Google Drive upload link as email, make sure that your upload's visibility is set correctly. Set it as who has link can view or download so that I can download it. 15. Everyone will be sending a Word or PDF document along with their final project files. This document will contain screenshots of your all comments to the lecture videos, all of the 14 lecture videos. Take screenshots with high resolution. Your comment has to be clearly readable. Those who fails to send this document will be counted as not attended to the lectures. Therefore, they will get FF.
Also, if you can't see your comment, sort comments by the newest date and check them from private window. If you still can't see them, you can repost your comment. Okay, this is the project details. So I think this is sufficient for this lecture. Hopefully see you at next semester or next year. Take care. End of lecture and end of the course software engineering.